array lists kind of are like strings in that they've got a lot of methods that come with. And I put a link here to I know this is real small for you, but you can follow the link. All the methods, these are the constructors, and these are all the methods. So when you're using array lists, either keep this link with you so that you can see, what can I do with an array list? Oh, I can add to it. I can clear it. What does clear mean? Okay, it takes everything out of the list. I can get. What do I need to get? There is an is empty, etc. So here are all the methods that you can have, that you can use with an array list. So I put the link here in your module. And let's look at these demos. Now you have to import. So import java.util.ArrayList, or NetBeans will do it for you if you forget. Zybooks does not, so you have to actually put the import into Zybooks. Or program in NetBeans, which is what some people do, and then copy it into Zybooks. If you do that, you have to make sure that you do not copy the package. That will cause an error in Zybooks. Okay, so here we have a new array list. This is our constructor for an array list. And here we are adding to the array list by using the method called add. And we're going to add first a string, and then an integer, and then a double. So already you can see that there is a big difference between an array list and an array. On line 10 here, I'm not saying how long this array list should be. And by default, it starts at size 10. So in Java, an array list starts out at length 10. If you have one that is of length 10, and then you say mylist.add and you want to add something else to it, that's fine. It automatically expands. This is not so with an array. An array, you have to say up front what its length is, what its size is, and that is fixed. You cannot alter that. An array is a dynamic structure. Dynamic meaning it can change. So it starts out at length 10 and then grows as needed. C++, for those of you, and I recognize that some of you hear this done C++, C++ has a similar structure called a vector. So not only did we not have to say how big this array list was, but we are putting different types of elements in it. With an array, everything has to be the same type. An array of ints, an array of doubles, an array of booleans, an array of circles. Here we've got an array list, and we put a string, an int, and a double in there. On line 15, we use the method get. Mylist.get. Mylist is the array list. .get. It gets the elements at position 0. So if I look back at what I put in my list, the first thing I put in was a string, and it was high. So when I get 0, it's going to get a string. The problem here is that because they are different objects that I'm putting into the array list, I have to then cast it. So I can get it. Let me see what happens if I don't cast it. Well, already it's complaining. So it says they're incompatible types. Object cannot be converted to string. So when you get something, it is an object. It's an object because this array list is an array list of objects. In the next demo, we'll find out how to make an array list of strings or an array list of ints. This one is an array list of objects because I use this default constructor. I said I'm going to have an array list of objects and I'm going to put any different kind of object in it that I want. But when I get something, it's an object. Yes, I put it in as a string. So it was a string. I put it into my array list, but there was a conversion that happened and now it's an object. And now I want to get it back. I have to cast it as a string in order to print it. Let's just see what happens. And here we are in my output. I get the word hi. So moving on, remove. So remove the element that is at 1. So what element was at 1? It was a 3. But I just removed it. So my list now consists of the string hi followed by 4.5. So if I say get 1, that's the 4.5, which again I have to cast into a double in order to output it. So now in my output I see hi and 4.5. And finally here, we can use an add. And this is a different kind of add. If you look here, it's just an add with something, and that adds something to the end of the list. So the first thing I put in at the end was hi. Well, my list was empty when it was created. So adding something to the end actually put it in at the beginning, if you know what I mean. I mean, it was empty when I created it. Then I added something to my list, kind of like a shopping list. It was empty. Now I put bananas on my shopping list. So that's my first thing. And then I add something. So I add it to the end of my list. So then I've got hi and 3. And then I add 4.5. So I'm adding 4.5 to the end of my list. So hi, 3, 4.5. This is a different kind of add. This has 2 parameters. The first is the index, and the second is the thing you want to add. So if I think back to what my list looks like here, my list is hi, which is a string, so maybe I'll put it in quotes, hi. Surely I can pick, there we go. That was the first one. Then I had I'm going from the beginning, then I had a 3, and then I had a 4.5. because I say get, it doesn't remove it from the list. It just means get the value of it and print it. But remove definitely removes it. And on line 18, I removed the element that is at 1. So I removed that 3. So that when I say get 1, I get 4.5. So when I get to add 8.9 at position 1, my list now, it was high, but I'm adding something at position 1 and I'm adding 8.9, and then that 4.5 got pushed back because I added the 8.9 at position 1. So now if I say get list 2, what am I expecting? I'm expecting 4.5. And you'll see in the output I got 4.5 twice. If I say get 1, meaning get 1, get something that's in index 1 and put it into T and then print it, then there's my 8.9. And so I can get anything I like from my list. I think I've just proved to myself and hopefully to you that I've still got high in the first place. I've got in position 0 at index 0. I've got 8.9 at index 1 and I've got 4.5 at index 2. Having gone through all of this, I have to say that this is not the normal way that we use array lists. But I wanted you to see that you can use array lists with different types of objects. You can put anything into an array list as long as you use this default array list, which creates an array list of objects. So what you're doing here is you're taking your high, you're making it into an object, and you're putting it into the list. You take the 3, you make it into an object and put that into the list, which is why when you say get, it's now an object. You have to cast it so that you can then do something with it. This is the more normal way that we use an array list. So you can see here that we have indicated the type. And here it is integer. So this is an array list, initially empty, but able to, initially empty, but of size 10. And an array list has to have objects put in it. They have to be objects. This is not so with an array. An array, you can put ints into an array. You can put doubles, lowercase d, doubles into an array. But this is not so with an array list. It has to have objects put in it. You saw that with the default was the class, the type object, which is the superclass. It encompasses everything. This myArray is going to have integers. It's going to be an array of integer. Now this is not int. I cannot say int. Already it's complaining, even if I put int in both of these places. I cannot have int. I must have an object. And in one of your Zybook's exercises, it talks about wrapper classes. So integer is the wrapper class. It's the thing that makes an int into an object. It doesn't do much. It's kind of a fake object because all that an integer has, integer, capital I, all that it has is a value. And then that value is, the value that it would have had it been an int. But this says I'm going to have an array list. I'm going to call it my array, and the only thing that goes in it, that can go in it, are integers. And then I start out with an int. I'm going to add this int. What happens? The compiler takes this int, promotes it into an integer, and then adds it to the array. I tried on the next line here making a new integer, value 7, and adding it to the array, and that strikeout is not from me, it's from NetBeans. It was telling me this was unnecessary. Yeah, it's unnecessary. I could have just put a 7 in there, which, is just like the line above. Here I make a new integer and then I add it. So that's another way of doing it. And now when I say get, I do not have to cast it because this is an array of integers. So I can say integer, if I could spell, integer x equals my array dot get 0. And my NetBeans has decided to hang. Okay, so when I get something now, I do not have to cast it. Here's another example of an array list, and this is using our dog class. So we see on line 9, we declare an array list of type dog. Line 10, we create a dog and then add it to our array list. Lines 12, 13, and 14, here we are dynamically creating them. So we're using our constructor as a parameter to the add method. Lines 17 through 20, I'm printing out the array list. I think if I were actually doing this not as a demo, I would have put this in a for loop, but I'm just showing you the 4 lines here with the gets. And again, we do not have to cast this because this is definitely an array list of type dog. We're using a loop, this new type of loop I showed you the other day. For every dog k in my array, so for every dog k in the array list, print it out. If I want to print it in reverse, I can't use this method because that prints them out going forward. So to print it out in reverse, I actually need a for loop, and I'm using one here. So I'm going to start at I, which is my array.size. This is not length now. Array list has a size and not a length. So it's size minus 1, that's the index of the, or the last index in the array list, and print them out. I don't actually like this last for loop because imagine that this was a humongous list, very large list. Every time I go through this loop, the machine has to calculate my array.size. That is a method call. So it has to call the method and find the size of the array list. It's much better programming if we take this, let's cut this, let's assign that as a value to something, int, I don't know, let's say length, just to confuse everybody, is size minus 1. And now I can go from len down. Yes, I've added an extra line of code, but every time through this for loop, I am not now calculating the size of my array list. And so I am speeding up my coding. In truth, this is such a small program that we won't notice any difference in speed. But one of the objectives of this class is to teach you how to program well, and so that means that you try not to calculate every time you go through this list, calculate the same thing every time you go through this loop. Okay.